Okay, by the way, we're starting to recording, and this one just make sure this assignment one, the 6 is different to the IPAs, so we need to just follow the 100 and then look in the 210 and the 310, right? Like this sequence. All right, so we were starting our new stuff. This today is for the lecture note 3, presenting diagram. We already learned it with AON. But we will hear more about the CPM calculations. So the CPM calculations, we will see there are 3 different documents over here. So that one is be announced as part 1. So the part 1 is kind of like to review what we have learned in the lecture notes 1. So because you will see the printing diagram, but we will another name active on the node is a network. It's most common used one right now. It contains a series of nodes, and each box is a node and a series of the links or the lanes. We prefer to use the arrows, right? And for this one, we're always looking from the left side to the right side. So we're reading from layout to end of the install, right? So so there are some advanced relationships we do not know yet is finish to start. We already know it. That's a very simple one. There are some advanced like finish to finish, start to start, and start to finish. So what that means, let's take a look at it. So first is a very simple one. What is finish to start relations? So each activity depends on the computation of its preceding activities. For example, you have place your concrete for 1 day. Once it's done, once it's finished, and then you can start to do your carry the concrete. And once you carry the concrete finish, and then you will do your strip the concrete forms, right? So that's do one by one in the sequence. So that's the finish to start. Finish the first one, and then move into the next one, or start the next one. So that's easy one. So keep in mind this one. We can use the different relations to present this one, even how without the carry the concrete for 28 days. So so if we do a finish to start relation like this, you can see we just remove the carry the concrete for 28 days. And we're putting a slash 28 here. So that is a log. The log is means you delay that days to do something. So we only introduce this in this class. We not really use this for calculation because if we do this calculation and then we'll get very, very complicated. So I keep you guys simple, right? So this is kind of a finished start with a 28-day delay, looks like. And this is the project we did it before, the case study we did it before. So looks like this, right? We already checked the answers, right? So this is a sequence number how we calculate we already introduced, right? So this case study we already did, and this one you just finished your quiz. So and this is the relation put in Gantt chart. So that is we already done it. So here is come with a new stuff. The new stuff is finish to finish relation. So that is means when you finish your activity, in the meantime, another activity is finished as well. The doing in the same time, the maybe start in the different, but they should be ending in the same time. Does that make sense? Yes. So if the finish to finish is over here, then we also have some relationship. We start in the same time, right? So that will be the start to start relation. So some of the examples showing here, you'll see this posting the flag pulse is same as backfilling the hole because you need to do the same thing. Do that in the same time. Make sure your pearl has been secured with those backfilling things, right? And then this one is finish to finish with a delay. So for example, you have this one. You will do your brick facades, and then you will install your windows. So you need to make sure those two is doing the same time, right? No, this actually not doing the same time. Doing the same time is your bricks around the windows should be the same time as your windows, right? Because you need to lock them, right? So in case of this, you can represent finish to start as this one. This is simple finish to start, but you can also switch it to finish like this one with a delay for some couple of hours or days, right? So yeah, the first one is finish to start, and this one is finish to finish with a delay.
The labeled one?
This is finish to finish. This is finish to start. Okay. So convert finish start to finish will be look like this. Any question for this? All right, so we move into the next one. So for this one, you will see finish to finish with a delay relation. And you can say remove the out panels will be in the same time finish with this sanding or the prepping the wooders, right? But this will be delayed because if you don't remove everything, then you cannot paint or sand it, right? And the same for this one. Once you sand it, then you can do the painting. So you will see 1 day delay and a 2 day delay to make sure you have the time. So if you don't want to represent like this way, definitely you want to remove the pen. You may already start with it. And in the meantime, you may divide this wall into 2 different sides, left and right. You can start it, remove the left side, and then once your left side down, you can do the sand, right? When the left side down, you can do the paint. So that is more likely when you divide or something into the different sections or the face, and then you can do like a finish to start, make it clear, or you can do like this finish to finish, make the drawing simple, right? So since this may be confusing you, so we're not using this one for the calculation. So start to start, as I mentioned earlier, you have your spread your growth and your set the type flying in the same starting time, right? So on the start to start is also may have something like called with a delay. So we will do it late, but we can see an example over here. Construction your start works and begin your wall installation will be ended by install the drywall and complete the wall installation, right? So you can also using those start with a delay. So you install your wall installation and then you install your drywalls. That means you're starting from fixed section A and then you do the section B, right? For install wall installation. But when you're doing the drywall, when your section A finished, then you can do the section A and then move to section B. So same thing. So additional example with two multiple additional delays. So but that is the same way you divide into the different phases, right? So all right, so and this one is even how contain activity with start to start and the finish to finish relation. So that means you are start in the same time and also you finish in the same time. But you see the numbers over here, that means they have some delay. So you will see this delay number 1 day is actually the same as this delay number 1 day, right? And this number 2 day and this number 2 day. If you have this or in 2 sections, that means do 1 section, you will cost about 1 day. And then this one, this activity will cost 2 days for 1 section. So can likely more complicated and more information to given to you, but it will cost you misleading or calculation difficulty, right? So this another one we have is start to finish. So you start to operate the concrete and then you finish or place your concrete. So that is really weird things. So the completing of your activity depends on the start of its preceding activities. Does that make sense? Do you guys have any question for this one? So if all those without the label, it means finish to start. You lay out foundation, then you dig foundation, then you place your framework. You obtain a rebar and then you cut the rebar. Does that make sense? You starting cutting your rebars when you audit your rebars, when you obtain your rebars, when you finish obtaining your rebars. Does that make sense? You're starting to place your concrete when you finish auditing your concrete, right? So so we may need to reading from here and back to there. So the computation of activity depends on the start of its preceding activities. Does that make sense? Remove those is make sense, right? And remove this is make sense. So let's see this. If that makes sense, start to finish with a delay. So the sense over here is only one start with finish with -5 delay. -5 delay. You order your concrete from the supplier and place your concrete in the form. So you need to order it early. And you can add in the -5, that makes sense. Go ahead. Which one? Or concrete from suppliers, yes. And come before you place the in frame, right? Yes, should be before it. Yeah, this one should be done before this one. This is a line connect. Oh, other side, okay. Other side, okay. You see here. Yeah, because from here you have it, right? But from here you don't have it. Why? Because you have the, it's not means you can do it anytime. See, here has a -5. Here is a negative because when you're adding the bus relation like finish to finish, start to start, and start to finish, you can simplify this finish to start relations to only 1, 2, 3 lines. And here has 4 lines, right? We reduced this one because you given a relation change. This one to that one is start to finish with a -5 days delay. So with this -5 days delay, that means you need to do it in advance for 5 days. Okay? So that now means if you can do it whenever. You should do it before 5 days. So if we're doing the calculation, you will notice that is correct. But if we do not do the calculation, so just think about you have something to do in advance 5 days. That means after 5 days, you will do the next one, right? All right. So eventually we're not using this for calculation. So you guys will be much more easy. That's just an example to give you some idea about what is start to finish relation, finish to finish, and start to start relation. Yeah. Yeah. No, you don't need to have a drawing like this. Okay. Just introduce to you, okay? So additional example over here, you will complete your step wall construction and you will set your prefabricated trusses, right? And you will order your trusses 45 days before your placing, right? So something like that. So same as order the concrete supplies. And this is also the same thing. When you want to do the inspection, you need to call 3 days in advance. When you place the concrete in the to order it 3 days in advance, right? And that is same way you want to erect your scaffolding and you need to contact your training 10 days before you do your install it, right? So so this is kind of like an example. We're not going to do this one because it will be confusing. So we were doing this one, but after we introduce what is CPM, okay? So we will go back to see those calculations. So that is the lecture note 3, part 1, presenting diagrammer, part 1. So we will have the part 2 is called the CPM calculations. Okay, so we are going to open this one and quickly introduce something, and then we have some challenge over this one, and we will do more practice this one in. We will do more practice about this one on Thursday. So so from this one, we will learn the basic definitions. Some of them are already learned, and then we'll be able to perform the calculations, right? So so first we need to know what is project. So in the project for the scheduling, that will be a set of activities with a defined starting and ending points. That is start time and end time, right? For the activities, will be a specific task or the job with defined starting and ending points. And for the events, that will be the starting point or ending point of any activities. It does not require any time for itself, right? We already introduced that. So now the important thing for this semester is called critical path methods. So the CPM, we show that CPM is a planning and scheduling technical in which a network, the AON or the percentage, is properly showing the interrelationship between the activities and the sequence. So we already mapped all those things, and the CPM for here is more about the calculation. So there are two types of the percentage diagram. So we introduced the percentage diagram or the we call another way percentage diagram PDM or AON. But the arrow diagram we call AON, we did not introduce yet. We held it after we finish this one because I don't want to confuse you. So so for the diagram, you just see the example. They have some box, right? So here's the definition for each of the box. We normally have 3 by 3, 3 row and 3 column like this one. And in the middle column over here, we define the first one as the atom. Let me download this one. This one is not showing very well. Okay, so we define a legend like this, a 3 by 3 box like this. In the middle, we will see the ID number. So the ID number is ABC, the label you define, right? Description, we normally don't put the description in our standard calculations. So if we're doing like computer software, then we can put a description over here. And the last one we have here is the duration. So the duration is this activity will cost how many work days? 1 or 2 or 3 or even more, right? So we were given the information to you. So and if you look in the top row here, we have ES and EF. So the ES is means early start, EF is means early finish. So we already introduced it. ES is means your earliest time the activity can start, and the EF is earliest time the activity possibly finish, right? And then we move into the last row here. We will have LS and LF. Late start and late F. The late start is activity can start and not impact the project computation. So because each activity may have its flexibility, it can move in, delay or moving ahead, right? So it depends. And then the late finish is a late activity can be completed without impact the project computation. So why that is important? When we're doing the calculation, we're understanding why. So in the middle row here, we have a TF. So the TF is called total float, and the FF is called free float. So they are very different for those two. So free float is amount of time by which the start of the activity or the finish of the activity may be delayed without causing the project to last longer. That means the project duration is still the same, but your activity can free to move. You will not impact anything else, right? That's your total float, sorry. And your free float is amount of the time by which the start of activity or the finish activity may be delayed without delaying the early start time of any succeeding activities. So the difference between the two is the total float is not impact your project last longer. And the free float is not impact your next activity, early start time. So that is more stricken than the total float, right? So free float is more stricken than total float. So, and then what result in your free float for activity, FF is always less or equal to its total float. Does that make sense? Yeah, we were using this one later. So let me emphasize here again. So TF is without impact the project. FF is without impact the earliest start time of your next activities. So remember those definitions is very helpful when you're doing the calculations, okay? So another terms we have here is called the critical activity. Equal to FF equal to 0. So if an activity have this total float is equal to its free float equal to 0, then this is a critical activity. So you may have multiple activities as a critical activities. If they come starting using a chain or row, a string to cross out them together, then you are putting critical parts from the starting to the ending. And that will be the critical parts for this project. If any of the activity delay in that critical parts, then your project time will be extended. So once we understand all those definitions, and we can introduce the calculations for you. Okay, so for doing the calculation, there are two technicals. So one we call that is forward part. So the forward part means your calculation is starting from your first activity and then by your last activity. If we're reading the network model, that will be starting from your left side and ending to your right side, right? So we're starting from the left side. So you are performing to find the activities early start time and early finish time. And also you can determine your project duration. So that's the key information here. So we are using the forward parts to determine ES and EF, and then we can know our project duration as the early finish time. So here's the formula. So when we're starting from here, in this CPM or preceding calculations, even how you have access to the textbook, do not look in the textbook, okay? Do not look in the textbook. Textbook is more complicated than this one. This is a much more easy thing to follow. Do not look at the YouTube, except my YouTube, okay? Do not look at the YouTube posted by someone else. You will get confused, okay? So I put the video recording on the YouTube so you can easily access it. So using 0 as the early start time for your first activity. What that means. So you will find your first activity and putting 0 in its early start time box for here, right? And once you define your early start time, and you know your activity duration, you will be able to get your activities early finish time by using early start time plus your duration, you will get early finish time. So we'll introduce here and then we'll demo how to do it, okay? So your early start time will be the largest number from your previous activity early finish time. Is that equation make sense to you? The EF, for example, you have the two activity A1 and A2 here, and you have your following activities B. So both A1 and A2 should be finished, and then you can start with your B, right? So that means the early start time for B will be determined by either A1 or A2 early finish time, and then you are using the largest one. It's because if any of them did not finish, then you cannot start it. So you need to make sure all the two finish and then you start with it. Okay. So remember this one, ES is equal to the maximum of your EF, your previous activities. So once we introduce the forward parts, we understand the EF, ES, and the project duration, and then we're moving to the backward parts. The project duration has been defined as your last activity's early finish time. Then you are moving this EF come down to the LF, starting with your backward parts. So your backward parts is from your last activity back to your first activity. That is the backward parts. And also means it's from your right side to your left side. So let's take a look at the equation. So you are using your calculated project duration as the later finish time for your last activities. So if suppose this is your last activity, your early finish time coming down to here as a late finish time. So once you determine your late finish time for your last activity, then you can, using the formula, late finish time minus your duration, get your late start time. You get your late start time, and then you are coming to the formula over here. You have activity A, which have two following activities. The latest start time is given because you, from the back to front, you're already getting the LS for B1 and RS for B2. So how to determine your LF for A? So your LF for A will be the minimum of your following activities, LS. So we did it before is using maximum because we move forward. Right now, we come back from the later to beginning. We cannot impact of them. So we need to do it using minimum. Okay. So the latest finish time for A is equal to the minimum from the LLS for B1 and B2. Okay. LS for B1 and B2. So that's the definition under the two backward and forward parts technicals for the calculation. So that is used to determine the late start and late finish. Once you determine your early start, early finish, late start, late finish for each activities, and then you are able to do your two float time, a total float and a free float. So a total float calculation is really easy. Refer to the total float. What is total float? Without impact your project, right? Without impact your project. What is free float? Without impact the early start time of your following activities, right? So that makes the total float is more than the free float for activity. So you will see the total float is equal to its late finish time minus its duration minus its early start time. So you can do all the calculation within the activity. But if you move into see what is free floats, it will be looking for the following activities because you cannot impact your following activities early start time. So you are definitely using the early start time for your following activity, choosing the minimum one from it to manage its own early finish time. So you get equation. Free float for this one is equal to early start time from the following two activities, choosing the smallest one, and the manage with your own early finish time, right? Because you're finishing and then you can start the next one. So with the understanding of those equations, we are going to solve a problem like this. Should we have additional time? So how to do this? So we have 1, 2, 3, 4, 5, 6 activities. We have the labels for each from A to F and the duration for 2, 6, 5, 3, 10, and 4. And we have the percentage. AA, CA, BDE. So can you draw a diagram for this one in real quick, 2 minutes? Go ahead, do it, yes. I give you 5 minutes to do this, including getting the sequence number. So this is percentage, this is not success, okay? This is IPAs. Getting your sequence number over here and have your diagram. Okay, so there's an additional practice about this one. You should be able to perform it in time. Getting tricky, yeah. So sorry. Okay, yeah, no problem. Yeah. Did anyone finish it? Yeah, we're asking you to do the practice, even how you have access to these slides. Don't jump to the next one. Okay, so you can do it before you come to the class. You can look at it. But when in the classroom, please try to do the coachable personal practice, right? So just look at the problem. Have to do the parts, to do the diagram. This won't be a challenge. Yeah, use A, B, C, D, yeah. So this class is the most challenging.
Okay, yeah, tell me.
So I mean, in your CM quick class, your 4 years, this is the most challenging. And the most challenging part is these CPM calculations. Yeah. You did it?
Please.
So it looks like B, C, and you should be. Receive something from it.
I do. A right there.
That's
A
not
goes
the
to B, and then C. A goes to B, A goes to B. C goes to B. It's the, look, A is the 5 and 2, 5 and 2, 2 plus 0, 2, thank you. 2 minus 0, 2, 7 minus 2, 5, 10 minus 7, 3, 20.
That's not much.
Yes, it is.
Very relaxed.
It is.
I can't get that motherfucker. I always think that.
So when I ask you just to do the joins, just do the joins. So later on, you can easily convert the joins to the calculation with a box. So just do the joins. Just to do the joins when you know the relation, and then you want. Okay.
You don't know that shit.
I do, I just. Your brain can't find that make
Sure.
All right. So you guys need more time?
No.
No, you just go ahead to see the result, right? Okay, so let's go ahead to see the results. So the first step is drawing a network. We put a PDM here because the presenting diagram methods. So we just needed to draw a PD, presenting diagram of AON. So you can easily get in this like this. You all get this? Same as this one?
Oh, I mean, yeah, I know how to connect it, but the numbers are something to each other.
So we're not teaching the number yet. Why you guys move forward, right? So we only teach. I'm not starting to lecture how to do the calculation. Did not give a demo yet. So not move too fast. Okay. So make sure you get this one, right? So now you get this one. You will convert this one to the diagram. So when you convert this one to the diagram, make sure. I prefer to using this legend. So EF, ES, LS, LF, TF, FF, ID, description, and duration. So 9 box, 3 times 3. So putting this one beside this diagram, okay? Putting your legend beside your diagram, and then you will do it for each of them. Okay? Putting the legend beside your diagram, and then you will do this 9 box for each of them. Okay, so you have 6 activities, and that means you will do a box over here. You will do a box over here, right? So do the 6 box for all them. So when you're doing the assignment, quiz, or exam, do the same way. Okay, so when we do the exam, actually I'll ask you to separate these procedures from your diagram because I need to make sure you're getting incorporated for this. Okay, so when you do without them, and then we move into the next slide over here is you say bone. Everyone has a box over here, and the number is already being filled out in. It's for easy you to catch it. So how we started. To remember, when we're doing the forward parts, we are starting from base A to the end of the F, right? So, so this is your starting activity. You are assigned 0 to its early start time. So this is your early start time box. So you assign a 0 to here. Okay? Assign a 0 to A. And the next one you will do is using the equation, early finish time is equal to your early start time plus your duration, right? So early start time 0 plus your duration 2, you get early finish time 2. That is the way we do this. 0 plus 2, we get a 2. And when you're looking for the early finish time for C, this early finish time for C, so early start time for C is actually come from this early finish time of A. So you move this A to here. And there's only one relation between A and E, so you move this 2 to here. Only one relation between A and B, move this 2 to here. Okay? And you can add in the duration, get a 7, adding the duration, get a 12, adding the duration, get 8. So that is the easy way, right? And you can do the same from C. You have early finish time 7. So the D have early start time is 7. 7 plus 3, you get 10. So now you get into the F. Challenge happen. So how many activities before the F? We have 3. From D, E, and the B. And the early finish time for D is 10. Early finish time for E is 12. And the early finish time for B is 8. So we have 12, 10, and 8. We want putting a number here, so we need to using the maximum one. Why?
That's the process. Okay, project.
Yeah, so if you're choosing this one, 8, those two did not finish yet, right? If you're choosing this 10, this E did not finish, right? So you need to choosing the largest one, 12. So once you get the 12 is early start time for F, you plus the duration 4, you get a 16 as early finish time for here, right? So this early finish time is also the project duration. So so the next step is you are going to define the project duration here. So any question for this forward pass? Question? Before I move into the backward pass, I need to make sure you guys are understanding this forward pass. Question? Question? Not ready? Are you need more time?
Yeah, please don't move on. I'm still kind of confused.
Okay, so if you don't move on, I will stop here. I will stop here. Yeah. I will stop this one for today. You guys can take a review and you guys can ask them questions next class. Okay? I will stop it for today. It's too much.
So would this be a
Look, this is only a partial of the Our final answer will be falling out those parts. Okay? This is only. So the final answer, every box will have a number. Okay? So but from now, you already know your project duration. But we still not know the late start time, late finish time, the total food and threshold. We only know the early start, early finish. So I'm stopping here. And you guys can take the time to review those stuff, right?
Yeah, we need to find the total flow.
I don't know.
Yeah, we need to find.
Flow.
Yeah. We need to find all those.
Yeah, those, okay, yes.
That's what is the next class. Okay.
Oh. So there's something that's two to do with this. We just have to do You say you have a Sunday, right?
I just
We have an assembly due next Tuesday does not have those things. The assembly due Tuesday is all the things covered by last week. But before this week, the assembly one is everything before this week. Okay. Josh, question? Can you see last? Yeah. Yes, because it's part of
Why you didn't give him the paper? The paper?
Yeah, because it asked for a hotel and the hotel number.
Right, but
And
in the
the,
email that.
No, I-
oh, did I?